late 2014, satellite imagery over the Jiangnan shipyard in Shanghai revealed a hull block so massive that Western naval analysts initially logged it as a new amphibious assault vessel. When the bow modules finally aligned with the midsection, the realization hit the naval intelligence community like a physical blow. The People's Liberation Army Navy was not building a frigate or a standard destroyer, but a 13,000-ton surface combatant. This was the Type 055 destroyer, a ship with a displacement over 30% larger than the United States Navy's Ticonderoga-class cruisers. The sheer scale of the vessel tore up decades of assumptions about Chinese shipbuilding capabilities, proving they had moved past reverse engineering Soviet castoffs and were now dictating the pace of blue water naval architecture. For decades, the Chinese surface fleet operated strictly as a coastal defense force, characterized by short-ranged vessels that relied on land-based air cover. As Beijing began launching aircraft carriers, their admiralty ran into a brutal operational wall. A carrier strike group operating in the Philippine Sea or the deep Pacific requires an impenetrable air defense umbrella, and their existing ships simply could not provide it. The older Type 052 Delta destroyers, while highly capable, lacked the internal hull volume and power generation to host the kind of massive radar arrays necessary to track incoming ballistic missiles or stealth fighters over vast oceanic distances. The Chinese High Command needed a centerpiece escort that could project absolute sensory dominance over hundreds of nautical miles while surviving saturated enemy missile attacks. They needed a cruiser in everything but name, built from the keel up to shatter the maritime status quo and force the United States Navy to completely rethink its Pacific strategy. Achieving this required abandoning evolutionary upgrades and committing to a revolutionary blank slate design that pushed Chinese metallurgy, computing, and marine engineering to their absolute limits. If detailed technical breakdowns of naval architecture and maritime strategy interest you, subscribe. I have got more of these coming. To achieve true sensory dominance, the designers had to first ensure their own ship could survive long enough to use its weapons, demanding a completely new approach to structural stealth. The naval architects adopted a flared hull form that smoothly transitions into a tumble-home superstructure, meaning the sides of the ship angle inwards as they rise above the main weather deck. This geometric discipline is not for aesthetic appeal. It is a vital engineering choice designed to drastically reduce the vessel's radar cross-section. By enclosing the mooring decks, hiding the heavy anchor chains behind flush-fitting panels, and integrating the main mast into an enclosed faceted spire, the engineers ensured that incoming radar waves from enemy ships would scatter into the atmosphere rather than bounce back. However, burying all these essential deck fixtures creates an immediate operational nightmare for the deck crew handling the ship's daily routines. Enclosed mooring areas become deafening echo chambers of grinding steel when handling heavy chains in rough weather, trapping dangerous tension forces inside a steel box. The lack of open deck space means sailors must perform complex, physically exhausting line-handling tasks in cramped, poorly ventilated compartments, while the massive ship pitches and rolls in the open ocean. A task that would take minutes on an open-deck frigate becomes a slow, highly coordinated, and inherently dangerous evolution in the confined shadows of a stealth warship. The defining visual and technical feature of the Type 055 destroyer is its integrated mast, a towering monolithic structure completely devoid of the spinning antennas and chaotic wire rigging that clutter older generation warships. Inside this sleek mast, Chinese engineers packed an array of dual-band active electronically scanned array radars. Operating in both the S-band for long-range volume search and the X-band for low-altitude horizon search and fire control, these flat-panel sensors act like thousands of tiny independent radar eyes. Because the ship does not rely on mechanical rotation, it can scan the skies instantaneously, shifting its electronic gaze from one horizon to the other in fractions of a millisecond. For the radar operators sitting in the dimly lit Combat Information Center deep within the hull, this technology translates to an unprecedented level of situational awareness. Instead of watching a sweeping line on a circular green screen, they look at continuous real-time tracks of sea-skimming missiles, high-altitude stealth aircraft, and surface contacts hundreds of nautical miles away. The ship's combat management system processes immense volumes of tracking data, automatically prioritizing threats, calculating interception geometries, and assigning defensive weapons faster than humanly possible. During a saturated fleet engagement, this digital brain reduces the cognitive overload on the command staff, allowing the captain to make tactical decisions rather than manually managing the ship's defensive posture. Yet, this electromagnetic omniscience demands a terrifying amount of electrical power and generates internal heat capable of melting the ship's highly sensitive circuitry. Active electronically scanned array panels are essentially massive microwave emitters, and pushing them to their maximum detection range requires pumping megawatts of electricity through the bulkheads. To prevent the radar arrays from literally cooking themselves into liquid slag, the ship utilizes an elaborate, highly pressurized liquid cooling network woven throughout the superstructure. The continuous flow of chilled fluid is the lifeblood of the ship's sensor suite, silently bleeding off thermal energy into the ocean. This elegant thermal solution instantly becomes a catastrophic vulnerability the moment the ship takes battle damage. A single failure in this pressurized cooling system, whether from a near-miss explosion or shrapnel damage, would instantly blind the ship by forcing the automated systems to shut down the main sensors to avoid electrical fires. Consequently, the damage control teams must constantly monitor thousands of valves, high-pressure pumps, and kilometers of piping embedded in the walls. They train endlessly in the sweltering darkness of the engineering spaces, knowing that a minor coolant leak during combat could be just as fatal to the ship's overall defense network as an incoming enemy cruise missile. To generate the electricity required by these ravenous radar systems, the naval architects had to overhaul their approach to marine propulsion, moving away from legacy steam and basic diesel plants. The Type 055 destroyer relies on a combined gas and gas propulsion plant, utilizing 4 massive gas turbine engines capable of producing a staggering 150,000 shaft horsepower. This brute force translates to a top speed in excess of 30 knots, allowing the mammoth vessel to effortlessly keep pace with nuclear-powered aircraft carriers during high-speed fleet maneuvers. Unlike older steam turbine plants that require hours to slowly build pressure before getting underway, these gas turbines can spool up from idle to maximum thrust in minutes, granting the ship exceptional tactical agility. But marine gas turbines come with their own brutal compromises, primarily their voracious appetite for fuel and their requirement for massive amounts of atmospheric air. To feed these 4 screaming engines, the ship features gigantic intake trunks that consume valuable internal volume and create potential acoustic echo chambers deep within the hull. Because the ship does not feature a fully integrated electric propulsion system, the powerful turbines are mechanically linked to the propeller shafts through massively complex reduction gears. These gearboxes are engineering marvels designed to step down the insane rotational speeds of the turbines to a manageable speed for the propellers, but they are also immense acoustic liabilities. The intense vibration and metallic noise generated by 4 turbines and their gearboxes spinning at high revolutions must be aggressively dampened, otherwise the vessel would announce its presence to hostile nuclear attack submarines across vast distances. To mitigate this, Chinese engineers utilize elaborate acoustic rafting, floating the entire engine assembly on flexible mounting blocks to isolate the vibration from the steel hull. Inside the engine room, it is a deafening, sweltering environment where mechanics wear heavy noise, canceling headsets while navigating narrow steel catwalks. They spend their watches constantly wiping down oil traces, checking vibration readouts, and monitoring gearbox temperatures in a relentless, exhausting battle against mechanical friction. The true teeth of this dragon, however, lie buried beneath its flush front deck and amidships sections, waiting in silent steel silos. The Type 055 destroyer is equipped with 112 vertical launch system cells, divided into a massive forward bank of 64 and an aft bank of 48. Simply citing the number of cells fails to capture the sheer lethality of this design, because unlike the Mark 41 vertical launch system utilized by the Arleigh Burke flight, 2 Alpha, the Chinese cells are uniquely cavernous. Measuring 850 millimeters across and extending up to 9 meters deep, these silos are among the largest standardized naval launch cells in the entire world. This immense internal volume allows the ship to carry significantly larger, longer-ranged missiles than its Western counterparts, directly altering the geometry of naval engagements in the vast stretches of the Pacific Ocean. Furthermore, Chinese engineers utilized a universal concentric canister launch system capable of executing both cold and hot launches from the exact same grid. In a hot launch, the missile ignites its rocket motor inside the silo, blasting a column of scorching exhaust through a dedicated gas management flue that vents the inferno away from the ship's deck. In a cold launch, a compressed gas generator violently ejects the missile out of the tube like a massive mortar shell, and the rocket motor only ignites once the weapon is pushed safely into the air. The ability to mix both launch methods within the same grid gives the combat commander unparalleled tactical flexibility when designing their weapon loadout. They can load delicate, slow-burning cruise missiles alongside brutal, solid-rocket air defense interceptors without worrying about catastrophic exhaust plume, cross-contamination destroying adjacent weapons. However, maintaining the volatile explosive charges required for cold launches alongside the thermal shielding needed for hot launches creates a massive logistical headache for the ordnance crews. Knowing what you now know about the immense complexity of managing hot and cold launch systems side by side in a pitching hull, do you think the design trade-offs were worth it? Share your thoughts below. This oversized launch grid facilitates the deployment of the single most controversial weapon in the modern Chinese naval inventory, the Eagle Strike 21 anti-ship ballistic missile. Until the deployment of the Type 055 destroyer, ballistic missiles were entirely the domain of land-based rocket forces or specialized slow-moving submarines. By successfully integrating a hypersonic, maneuvering ballistic missile onto a highly mobile surface combatant, the People's Liberation Army Navy fundamentally disrupted established American carrier defense doctrines. An incoming Eagle Strike 21 plunges from the upper atmosphere at terminal speeds exceeding Mach 6, drastically shrinking the reaction time available to defending cruisers and their automated point defense systems. The kinetic energy alone of a successful hypersonic impact would be enough to shear completely through the reinforced flight deck of a supercarrier, instantly neutralizing the vessel's ability to launch or recover aircraft. This threat turns the 13,000-ton displacement of the Chinese destroyer into a mobile strategic deterrent that forces enemy battle groups to operate hundreds of nautical miles further away from the contested shorelines. Complementing this offensive reach is an incredibly dense defensive payload centered around the Red Sea Arrow 9 long-range surface-to-air missile. With an engagement envelope stretching out to 200 nautical miles, these sophisticated interceptors allow a single destroyer to sanitize vast swathes of airspace, creating a mobile no-fly zone over the fleet. When operating beneath the waterline, the massive vessel hunts enemy submarines using a large, bulbous, bow-mounted sonar dome and a sophisticated variable depth towed array winch located at the stern. The towed array is a critical piece of acoustic espionage, unspooled on miles of heavy cable to sink beneath the ocean's varying thermal layers. These thermal layers act as acoustic shields where enemy nuclear attack submarines, like the ultra-quiet Seawolf-class submarine, attempt to hide from surface hunters. By dropping a listening device beneath this layer, the destroyer can hear the faint mechanical whispers of an approaching submarine long before it enters torpedo firing range. But towing a heavy sensor array through rough seas drastically limits the maneuverability of the massive destroyer, creating a dangerous operational paradox for the ship's commanding officer. If the ship detects an incoming torpedo while the array is deployed, the bridge crew is forced to make a terrible choice between executing evasive high-speed turns that will snap the precious cable or maintaining an unbroken acoustic picture while trying to outrun the threat. Sonar operators sit for hours in a darkened module, staring at cascading waterfalls of green digital noise, straining their ears to differentiate between the biological sounds of shifting tectonic plates and the rhythmic, deadly thrum of a hostile submarine propeller. When long-range missiles are depleted or the engagement range suddenly closes to within visual distance, the crew relies on the massive 130mm main gun prominently mounted on the bow. Housed in a stealthy, faceted turret to maintain the ship's incredibly low radar cross-section, this fully automated weapon is a masterpiece of kinetic violence. It can hurl 70-pound high-explosive shells at coastal targets or surface vessels over 20 nautical miles away, providing devastating naval gunfire support for amphibious landing operations. The gun barrel features a sophisticated liquid cooling jacket to prevent warping during sustained bombardments, while automated mechanical hoists drag heavy shells from the deep magazines up into the firing breech in a relentless rhythm. Should enemy sea-skimming missiles somehow leak through the outer defensive layers and evade the long-range interceptors, the ship's ultimate survival relies on its Type 1130 close-in weapon system. Mounted prominently on the superstructure, this monstrous 11-barrel rotary cannon is capable of firing an astonishing 10,000 rounds per minute. When this defensive gun activates, the sheer vibration violently rattles the fillings of the bridge crew, throwing up an impenetrable, terrifying wall of depleted uranium or tungsten fragments. It is a weapon of absolute last resort, designed to physically shred incoming supersonic threats in their terminal phase, leaving only milliseconds between survival and catastrophic hull failure. Yet, for all its terrifying specifications on paper, a warship is ultimately defined by its ability to endure the unforgiving, corrosive reality of the open ocean. Displacing 13,000 tons and featuring an exceptionally wide beam, the Type 055 destroyer is built for blue water stability, slicing through heavy Pacific swells with a long, graceful bow designed to reduce hydrodynamic drag. The bridge stands high above the waterline, offering the command staff commanding views of the horizon during complex fleet maneuvers. However, the heavily enclosed nature of the stealthy superstructure comes at a severe psychological and physical cost for the enlisted crew serving aboard. With almost no open weather decks and heavily tinted, radar-absorbing glass on the bridge windows, sailors spend months deployed in a sterile, artificially lit steel cavern isolated from the natural world. The physical fatigue of rotating watch schedules is heavily compounded by the constant hum of ventilation fans, the lack of natural sunlight, and the pervasive smell of marine diesel and ozone. Long deployments turn into grueling tests of mental endurance, where the crew must constantly battle the mundane miseries of living in a pressurized steel tube while maintaining peak combat readiness at all times. The ship may be a technological marvel, but it is entirely reliant on the exhausted, caffeinated humans maintaining its internal systems. The immense complexity of the vessel's interconnected systems creates an exhausting daily workload for the engineering and maintenance divisions. Saltwater is a relentless adversary, and the specialized stealth coatings applied to the ship's exterior panels require constant, meticulous upkeep to prevent rapid environmental degradation. When a radar-absorbent panel gets chipped by flying storm debris or pounded by a harsh typhoon, It does not just look cosmetically ugly, it creates a highly reflective surface that instantly ruins the ship's carefully crafted electromagnetic camouflage. The damage control teams must meticulously scrub, prime, and recoat these exterior surfaces while dangling in hazardous safety harnesses over the side of the plunging hull. Furthermore, the massive marine gas turbines and the highly complex reduction gears demand rigorous scheduled maintenance, requiring the ship to frequently return to specialized dry dock facilities for major overhauls. Naval engineering is a brutal zero-sum game, and the bleeding-edge technology packed into the warship demands a staggering logistical tale to keep the fleet operational. Every single day spent at sea degrades the mechanical lifespan of the pumps, the radar cooling pipes, and the acoustic dampening rafts. The sheer financial and industrial cost of keeping just one of these cruisers deployed in combat-ready condition places an enormous burden on the Chinese naval supply chain. To truly understand the strategic shockwave generated by this vessel, it must be placed directly against its primary maritime rival, the United States Navy's Arleigh Burke Flight 3. The American destroyer is undoubtedly a masterpiece of refined combat engineering, equipped with the phenomenal, highly sensitive Spy-6 radar system and backed by decades of unmatched combat pedigree. However, the Burke hull design, which originated in the late 1980s, is practically bursting at the seams with no room left for physical expansion. It fundamentally lacks the internal volume to field massive hypersonic missiles the size of the Eagle Strike 21, or the excess electrical power generation required for future integrated directed energy weapons. By starting with a completely fresh, massive 13,000-ton hull form, Chinese naval architects essentially bought themselves decades of invaluable growth margin. They can confidently integrate heavy naval lasers, massive microwave electronic warfare emitters, and even heavier anti-satellite interceptors in future mid-life refits without having to redesign the fundamental architecture of the vessel. The Type 055 destroyer was not built just to fight the wars of today. It was designed with the spare capacity and structural volume needed to accommodate the unknown, highly classified weapon systems of tomorrow. Despite this impressive growth potential and dense defensive armament, the cruiser is by no means an invincible supership, immune to the harsh realities of naval warfare. Its immense physical size makes it a highly lucrative and relatively easy-to-spot target from orbit, and its reliance on massive active radar emissions can sometimes serve as a blazing homing beacon for advanced passive electronic warfare systems. American fast attack submarines view these massive destroyers not as insurmountable, terrifying threats, but as high-value priority targets worthy of sinking. A single Mark 48. Advanced capability torpedo detonating precisely beneath the keel of the Chinese warship would break its back, instantly turning the technological marvel into 13,000 tons of rapidly sinking scrap metal. The Chinese Naval Command is acutely aware of this glaring acoustic vulnerability, which is exactly why these monolithic vessels almost never operate alone in contested waters. Instead, they act as the heavily guarded queens of complex, multi-layered carrier strike groups surrounded by smaller frigates and anti-submarine corvettes that form a protective physical barrier. Their primary mission is to stay alive, manage the airspace, and coordinate the destruction of enemy assets from distances that render traditional naval gunnery entirely obsolete. They are the ultimate command nodes, floating fortresses designed to dominate the electromagnetic spectrum while unleashing devastating hypersonic strikes across the horizon. The successful launch and rapid integration of the Type 055 destroyer marked the definitive end of Western naval complacency in ship design. It violently forced admirals in Washington, London, and Tokyo to accept the uncomfortable reality that the People's Liberation Army Navy had achieved sheer parity in surface combatant design. In certain specialized metric fields, such as vertical launch cell volume and hypersonic missile integration, they had arguably even surpassed legacy Western platforms. This ship is the undeniable physical manifestation of Beijing's ambition to push its defensive perimeter far out into the deep Pacific, claiming strategic dominance over vast swathes of previously uncontested international waters. Ensuring that any future conflict over contested island chains or critical shipping lanes will be fought against a highly sophisticated, densely armed adversary changes the entire calculus of global geopolitics. The long-standing era of undisputed Western maritime supremacy, where heavily armed carrier strike groups could sail unimpeded and unchallenged to any hostile coastline on Earth, effectively ended the moment the first of these colossal cruisers slipped into the muddy waters of the Yangtze River. Whether you view the vessel as a terrifying masterpiece of modern naval architecture or a highly complex, fundamentally unproven platform waiting to be violently tested in combat, its impact on the global naval balance is absolute and undeniable. The Dragon has grown its teeth, and the turbulent seas of the Pacific will never look the same again. If you found this analysis useful, a like helps more people discover these deep dives. Thanks for watching. Thanks.